2022 triple higher paper. So the first question, you usually see these diagrams with alternating current, but it's exactly the same with alternating voltage and then direct voltage. So state one of the difference. Well, alternating voltage continuously changes direction. So that's switching between positive and negative up the top there. And then this direct one doesn't change direction. We've got 3 scenarios. So we've got the mower cutting through the cable. That's a danger to the user. Too much current flowing through the main ring. Well, that's not really a danger to the user. That's a danger to the appliance, but not really to the user. Live wire touching the kettle, that is a danger to the user. So we've had to pick one of those, I think, and then suggest what circuit breaker is best to use. So if you choose number 1, it's going to be the RCCB. So that's the most sensitive one, the residual circuit breaker. If you pick number 3, it's going to be a fuse in the plug of the kettle or an MCB. That's a little bit more sensitive, but it can be reset, the MCB, okay? 2 advantages of an MCB over a fuse then. So it's faster acting because they're changing current, and then it can be reset, so you can reuse it. Whereas a fuse, it takes, even though it's quite quick, it does take time to melt the wire. So it's not as fast as the MCB. What does a live wire do? It carries current to the appliance at high voltage. A neutral wire completes the circuit and carries current back at low voltage. So all these definition based. So we should be knowing these for the marks. Question 2 then is on earthquakes. So remember now that P waves can move through solids and liquids, whereas S waves can only move through solids. So that's going to be important in the future question. So we can see the S waves here, P waves here, so they've got different speeds in different depths. Is that speed on the side? Yes. So, nice little question to start off with then. Definition of a longitudinal wave, vibrations are parallel to the direction of wave travel. So that's one of your definitions for 2 marks. Use the graph to calculate the difference in speed between P and S at a depth of 100. So you just go in there. So that's 1,000, there's 100, 1 square you go in. So you can see S waves 5, P waves on 9, because every 2 squares is worth 1 there. So it's 9 minus 5, and that's going to give you 4 kilometers per second. On to this question then. So it's giving you a distance of, there's one above that. Our Bob claims that the maximum speed P waves is greater than the solids in liquids. Explain using data from the graph. So I've gone to the data graph. I said max speed in the mantle is greater than the speed in the outer core, which means the mantle is acting like a solid, so it's going to be faster in solids than liquids. So that's why the claim is true. It's knowing that the mantle is acting like a solid. So if we go here, you can see that the P wave is faster than the S wave there, okay, in the Earth's mantle. You've got a distance of 6,300 kilometers, and then a time of 550 seconds. So I've written that there because that's going to be useful for this question now. Bob states that the mean speed of the P wave of the distance equal to its actual speed in the depth. So first of all, let's calculate the speed that it's traveling. So the speed equals distance over time from your front page. So that's going to be your 6,300 over your 550. That's going to give us 11.45 kilometers per second. Now, from the graph, the speed at this depth is actually, if we look, I've gone up there, it comes out as 10 kilometers per second. So the claim is not true because he's suggesting that it's equal to, and it's not, because that's 11.45, this is 10. So the claim is not true for 3 marks. If we've got another bit to this question, yes. So now what we've got to do is, we've got to know that at the center is liquid, and obviously S waves can't travel through liquids. So you're not going to get S waves here. You're going to get S and P waves here, but you're only going to get P waves at this point. So use the time given in parts. So we worked out we said the time was 550, but because now, the other diagram's all the way up here, it only went halfway in. Oops, I didn't want to do that. It only went halfway in, and that took 550 seconds. So now it's got to come all the way back through, so it's going to be double that time. So the time is actually going to be twice the time, so 1100 seconds there. And then we've got to draw that on the diagram. Now, I've actually done this wrong. I realised after I took the photo, I've done it at 1000 and it should be 1100. So it should be halfway. So this P, this little zigzag here, should be, in fact, let me get the pen. It should be, let me pick the right colour. So that's wrong there, it should be there. Okay, sorry about the thickness. So it's got to be a smaller amplitude than these ones. And you, like we said, we can't get S waves. So you're not going to have this one at any point down here. Okay, you're just only going to detect that P wave. The next question's on satellites then. I kind of disagree a little, for 4 marks. I disagree with this one slightly when it says that it orbits the Earth every 24 hours. It actually sticks at the same point above the Earth. So it does orbit it doesn't orbit every 24 hours, but I don't think it's not going to orbit the Earth every 24 hours, although the mark scheme says that it's right. Sometimes they give the marks if it's ambiguous, and I think this is an ambiguous one. The rest are fine, so read through and anything you don't understand, make sure you see your teacher about that, because it'll take me too long to go through it all in the video. We've got then the equation from there, just slightly rearranged to calculate for frequency. So I've got my wave speed over my wavelength. Don't forget, for that extra mark, to put hertz as your unit. And then we're told that this is the time delay, but that's there and back. So the big thing with these questions, you know that's going to be 0.12 seconds, because for something to go there and back is double the distance. You just want to go there. We're just looking for the distance that it takes to travel to the satellite. So you either do the calculation like I've done, where speed equals speed times time. So I've just used the time it takes, and then I'll half the answer. Or you can just half the time before it goes in there, and you're going to come up with 3.6 times 10 to the 7. Question 4 then is on, let me just straighten this up slightly, that's better, is on measuring density. I found this a little bit tricky at first, because what you have to do is realise that as you add in the volume, it goes up. So the mass starts at 68, and then goes 78, 88, 98. So it's going up in tens. So if you know you're adding 10 centimetre and it's going up in 10 grams, then the first question becomes easier then. So it says, one member of the group claims that the density of water is 1, and it is really, because it's increasing. If you increase the volume for every 10, the mass is increasing 10, so 10 goes into 10 one time, so it's got to be 1 gram. State the volume at which they started adding the ball bearings. Well, that's where it doesn't go up by tens anymore. That's where it's going to take a jump. So you can see the first big jump is from 108 to 187, and that's at the point 40, 50. So I think the volume is 40. Well, I don't think, I know, because it says in the mark scheme as well. Give a reason for your answer, and then I've tried, so the stops increasing by 10 after 40. Okay, so it jumps up a lot more. Use an equation on page 2, so that's going to be density equals mass over volume. And then I've picked 79 over 10, because that's the point at which where the difference is. So you've got the difference between 108 and 187 is 79. So that's going to take out that the density of water, and then 50 to 40 is 10. So that's going to be my volume. So it's mass over volume. So the difference, 79 over 10, is where I got that from. And that comes out to be 7.9. 2 improvements. Well, you can always have better resolutions on the measuring cylinder. So that means more increments on the measuring cylinder. Get a balance with a better resolution as well, more decimal places. You can even use smaller ball bearings if you wanted to get more accurate results, okay? Question 5 is your 6 marker from this paper. I'm not going to spend too long on this, because this is a standard 6-mark question on conduction, convection, radiation. It's really knowing that conduction happens between solids, heat transfer in solids, convection in fluids, and then radiation in empty spaces or vacuums. So for example, if you create a vacuum between 2 pieces of glass, you're going to reduce the heat loss via conduction and convection there, aren't you? So that's where we talk about these, okay? So again, any questions that you've got, rather than me making this video like 20 minutes long, which it probably will be anyway, any questions you've got on that, see teacher. It's one of your teachers. Coming to the end of the paper then, let's have a look on circuits. So we've got a bunch of resistors. This wire can move, so you can actually attach this there if you wanted, or you can attach it there. You can attach it anywhere. Remember now, because these are in because these are in series, the more resistors you add here, the bigger the resistance is going to be. The less the resistors, the less resistance is going to be. So it says move the connectors, move to point X, where there's no resistors. Why are we putting this safety resistor in? Well, if there was no resistor there, the current could be too high and it could actually damage the ammeter if the ammeter is really sensitive. So you need that safety resistor there that you know, just to be careful you're not damaging that to avoid the high current there. We've got a mean value there, so it's that one plus that one divided by 2, because you've got 2 readings, comes out to be 0.4. And then you've got to graph that. Oh, not yet, hang on, just a sec. State the value of the resistance when the safety resistor is, it's going to be this, oh look. That is when the safety resistor is total resistance. Let's have a look. So let me read that question. State the value of the resistance of the safety resistor. Yeah. So that means that there's no resistors attached. We're just looking for that. So if there's no resistors attached, it's going to be 10 ohms there. And then determine the value of the resistance of each resistor R. So let's look at the first one. It jumps up to 30. So the difference between 30 and 10 is going to be 20. So each resistor must be 20. Then we're going to draw that suitable line on the plotting. So I've just plotted, what have I plotted? I've plotted this one, which is on the bottom, which is unusual really, because this usually is our dependent variable, the thing that we're measuring here, and we're choosing the number of resistors, so we know the resistance. However, because then they've realised that and they've put it 1 over the current, so that's why it's a reciprocal. And sometimes you see that happen. You see a lot more of that in year 11. But anyway, that's all you've got to do is make sure you plot them correctly, okay? And then we go on to the next question, which is, use your answer in part B. And graph determine the current when 3 of the resistors labelled are included in the circuit. So, because we're not given results for the third resistor, we're only given results for resistor 2 and 4. So the total resistance, as we know, it goes up by 20 each time. We've identified that in the last question. So the difference between 50 and the next one is going to be is 20, so it's going to be 70 there. So now that we know that, I can use my graph and say at 70 ohms, the current is 1 over 5.8. So I'm just going to do that calculation, type that into the calculator. 1 over 5.8 is going to give me the answer of 0.17 amps. Okay? Use the gradient to determine the value of voltage. The gradient is change in y over change in x. So I've chosen, because it's a straight line, I've literally gone, change in y is 120 over 10 there. So that gives me 12 volts. Describe one other way the battery voltage could be used. Well, you could take some values from the graph, from the table, sorry, and just use V equals IR. You can also find out that way. Question 7 then, so 2 questions ago. This is a common question. Describe how Fleming's left-hand rule can be used. So you just need to know your first finger is going to be the magnetic field, so north to south in this case. Second finger is the direction of current, so the current is going this way, so back towards you. The thumb will give the direction of motion then. So if you actually do that, don't be afraid as well. Sometimes you see, I've seen people in exams with all sorts of shape on their hand. If you need to turn the paper around to suit your hand, do that instead of trying to break your arm into the position that it should be. Just turn your paper and everything will work out okay. By considering the current at AB, explain the split rings. Okay, so this is a good one because if it wasn't a split ring, so what we're saying here, let me just move that up, is that when this get put, so the motion is going to go up because the current is going this way. So it gets pushed up to a point where now the south is going to make the current go this way and push down. This is going to start spinning now because you've got a north and a south. If this was north and that was north, both currents would flow this way, therefore they both would get pushed up. So this would just be static, stationary. Because this is a south, it's going to push down, this is going to push up, creating that motion there. That's really hard to get into words, isn't it? So we say current changes direction in the coil every half term, so the force on the left is always up, the force on the right is always down, creating that spin. Okay, this one then, so we're given this equation, so we're looking for the force. We've given the magnetic field as 0.04 there. We're given the current, there's 0.7, and then we're given the centimetres, so make sure you convert that into meters, because length is always in meters. Complete the equation, nice little 3 marks there. Just give the value that the calculator gives you. So if it gives you 0.00168, write that in. But most of our calculators go in standard form these days, so just write the answer that the calculator gives you. Describe the effect on the force AB coil with doubling both battery and the number of coils. Well, doubling the number of coils is going to double your force, double your motion. And if we double the voltage, we double the current. Therefore, if we double the current, we know from this equation that if this doubled, then that's going to go up. So it's going to quadruple your force if you do both things, okay? It's going to be 4 times as much. Last question then, finally there, we're on 60 minutes, so it did take about 20 minutes after all. Let me just straighten this up. So we've got a lovely gas one now. Now this one is a little bit tricky, but it's all in the wording. If the temperature is constant, the volume of the column there decreases. Describe the effect, if any, on the motion of particles. Now, there's not going to be any change on the motion of particles because the temperature is constant. If you applied heat, then the particles will start moving faster, therefore more chance of collisions. So pressure would increase then. But because they're constant, there's no motion. But because you're making the room smaller, so think of like a class full of students, okay? If you make the walls smaller and we're all walking at the same speed because we haven't applied any temperature, there's more chance of collisions because you're just in a smaller room. So if you make that volume smaller and keep the particles, their speed the same, then there's more chance of a collision because there's a smaller space. At pressure then 1.2, the volume is 18. Explain without calculation what happens if the pressure is increased to 2.4, so that's double, at constant temperature. And remember, the key is now constant temperature. Those particles are not moving any faster. And you're tempted because when you think of blowing up a balloon, okay, that it gets bigger, but we're increasing the pressure. It's almost like that ratio of the equation. If I just show you the equation, which is back up here, where's your equation sheet? It's pretty much this one, PV over T. So if the temperature is constant, if one's getting bigger, the other one's got a half, right? So if your pressure's doubling, then your volume's got a half to remain constant there. So that's why it's a little bit tricky, okay? It kind of goes against your thinking, but the volume will half, it will decrease to half, 9 centimeters cubed there. And this is just number crunching now. So we're on the number crunching part. So the temperature, oops, didn't want to do that. The temperature, when you add the 273, which you can find from the equations sheet as well, to 27 degrees Celsius, you come up with 300 Kelvin. Now that we know that, we can use that equation I just talked about. Because if this is a constant, it's going to be exactly the same as, so this side is going to equal to that side. So P1 V1 over T1. Because pressure now, change in temperature, because pressure is constant now, 27 kept up. Oh, sorry, volume is constant. We're just going to deal with pressure over temperature. And when we rearrange this, so you got 2.4 as your first pressure over 300. Your second pressure is 3.0 times 10 to the 5, obviously. And then when you rearrange that, you can solve for your temperature. Now, I made the classic error of just writing my answer in there, and then I saw change in temperature. So it's your new temperature minus your old temperature to give you that 75 kelvins. And then we've got this, my favourite equation in year 10, MCAT, because that used to be the letter T for temperature change back in my day. So we're solving for heat capacity. So here's a little tip. Just use the numbers you're given before rearranging. Okay, so like I've done there, and you get 1 mark straight away. So if you know that the change in heat, so look, what's it got here? Change in thermal energy is that, just put it there, equals that. Fill in the blanks and then rearrange. Don't rearrange first. Because if you make a mistake there, you don't get any marks. That comes out to that. And that is the end of the paper. So I hope you got something from that. And any questions, go and see your teacher.